Hi, good morning. Thanks, Barbara, for the introduction, and thanks, George, for moderating as well. Thank you, everyone, for joining. Really happy to see so many faces, and I hope during this time of need that I can offer some assistance. My thoughts and my prayers are out to you and your loved ones, and I hope you remain healthy and sane during this time. Um, so I'm going to lead us through thinking through science instruction through distance learning. And I'm going to share my slides and begin the presentation.
As you're doing that, I want to remind folks that this is being recorded and we will post it on our YouTube channel. You'll get information about that later.
So today's presentation is hacking science instruction through distance teaching and learning. If you would like to stay in contact, my Twitter handle is on the bottom left of the screen. I also want to give a shout out to the Hybrid Learning Consortium. That is an organization that's been doing online and distance learning for many years. They are undergoing some changes. They will be known as Constellation Learning starting in July, and they'll be ready to rock and roll. But the people at Hybrid Learning Consortium are wonderful and competent people, and I'm just grateful for their support and my adventures in online and distance learning. So before I kind of talk through, I'm going to call them hacks for distance learning. I want to sort of reveal behind the screen some things that I do and how I set up my classes that might be helpful when you're thinking about distance learning. But this is something, this model I use for my brick and mortar class, and I found that it translates nicely to the online platform. So I use BSCS, I can't remember the name of the organization, developed a 5 e-learning cycle many years ago, decades ago, based on research and best practices for teaching and learning. And they developed this 5 e-learning cycle that I have adjusted for my purposes. And so as I'm taking my students through units, I go through 5 steps. I start with an engage, and that's a way to, it's sort of an entry point to the topic. It's a way to make the topic interesting and relevant. So it might be something I try to do controversial things where there can be a difference of opinion. And this sort of grabs the attention of students who don't typically see themselves as science students, and bringing in some of the other folks who like to argue or have discussions. So I'd like to start a unit with some kind of article or video that outlines a controversy that's related to the topic we're about to learn about. You can use an online poll. You can have a live synchronous Zoom discussion about that controversial topic or issue. You can use an online discussion thread, but it's a nice way to get all folks buying into the topic. Then I like to go on to some kind of exploration. I try to make that a lab. If not, it's some kind of activity. And that's a way for all of us to get some experience with the topic. Try to do it hands-on. And I do it in a way that there's some missing information. So there might be some questions or some tasks that they're able to do, but then I sort of, I give them some tasks that they're not actually able to do. And at the moment, I should say, in the learning cycle. And why? Because what I want to do is leverage the lesson. So I call the next step flip, and that's an instructional video. Typically, I like to be the one who makes those videos, or maybe there's a text that they read, and that's going to give them information. Reason why I point this out is because I worry at this time that a lot of teachers, especially maybe science teachers, are thinking about, hey, I'm going to direct students to a video, they're going to take notes, they're going to answer questions, do an activity, and then move on to the next and repeat, sort of like, wash, lather, rinse, repeat kind of thing. And I worry that that's not going to be terribly engaging for students. If you just kind of sort of force a video in their face, the question is, well, why am I watching this video? So I don't like to start a topic with an instructional video. I like to build in a reason for you to watch the video. So we've done this lab during the exploration. There's some content you don't quite have, and now I'm revealing the video or the lesson for you to get the content that's missing in order for you to complete the entire exploration. And then after the lesson, there's some practice. There's an opportunity to revisit the exploration. So maybe they're revising some questions, or maybe there are some questions that they weren't able to answer, or maybe now they've sort of come up with a model for approaching the questions or the task. And now with the information from the video or the text, now they're actually able to do the task. I typically like to have another lab or activity in this step as well. Problem sets are also useful here. And then I like to end with an assessment or different assessments for them to demonstrate their understanding. So I'm just gonna give you a brief example of what one of these learning cycles might look like. So this is a natural selection, evolution learning cycle. We start off in engage, and this is, they read this article about there are farmers who inject their livestock with antibiotics, and they found that doing that, we don't quite know why. We have some thoughts about it, but either injecting them or feeding them with antibiotics, actually the animals produce more meat. But those who know evolution and natural selection also know a consequence of that is the development of antibiotic-resistant bacteria. So there's an evolution of the bacteria who are now becoming resistant. The populations are becoming resistant to those antibiotics. And then we have a potential crisis of bacteria becoming resistant. And now we can't use certain antibiotics if people were to get sick. So it sets up a really interesting discussion where people are debating, maximizing, the food industry and why that's helpful, but also bring in this topic of evolution in a way that engages them, that is not just sort of, here's a video about natural selection and here you go. And then in the exploration phase, I have students do this online simulation, this lab activity, in which they're starting to develop a theory of how things change. So in the antibiotic article, they don't quite, they kind of get introduced to this idea of bacteria evolving, but they don't really quite understand the mechanism. So there's in exploration, they get some experience with kind of outlining, they start to outline, I have them outline a theory of how this might happen based on the activity that they do. But again, they don't quite have enough information. They just have that experience. That's when I hit them with the flip video where they take notes, they answer some questions, and they're starting to get more information about natural selection. In the apply phase, now they have some content where they can start to use some vocabulary and revise some of their thinking from the exploration. There's a problem set there. I'm not showing everything, by the way, in this slide. There's a problem set there where they get some more practice. Then I introduced some differentiated case studies where they're actually looking at natural selection happening in real life. And they're able to look at some data from some experiments. And then they come up with ideas about, like, why do we see, mimics in nature? Why do we see different skin color, and different things like that, where they're applying what they've learned in the first steps. And then assessments, I usually have some either online quiz, and I provide them with a choice board where there's a project that they can complete that demonstrates their understanding. So that's an example of a unit that can be done online. All this stuff can be easily done online. Some Zoom sessions, some of those discussions, maybe those differentiated case studies. Maybe there's a Zoom session where I break them out into their groups and they discuss some of those case studies that's been assigned to them. They're submitting things online. So this can be easily done online or through a distance learning platform. So now, so the agenda for the rest of the period is I want to sort of give you some concrete examples of things that you can do, certain problems that you can solve. So I'm going to take us through what I call hacks. One is hacking the scientific process. So I think a lot of folks are interested in how do you approach labs, you know, in a distance learning way. So I have some ideas about that, or at least recreating some of the lab experience. And then another question is about content delivery. So how are students going to learn the content through a distance learning situation? So that's the way I'm going to spend the rest of my time here. So one solution that's not an easy solution, and it is an expensive solution, and I think for those who are in schools that have the means to do that, one of the sort of most, the option that's most similar to what you would do in a brick and mortar class is you can have labs mail delivered to your students. There's something called HolScience, hands-on lab science. You'll see the URL on the bottom left-hand corner. This is, if you think about, you know, some of the vendors that you use for your labs today, so like Carolina Biological or Ward Science or a bunch of those other vendors that you use, and they mail the all the lab supplies to your school and all the teacher instructions and multiple copies of everything. But HolScience will actually mail individual lab kits to your students, so you can have that ordered for them, or they can order it. You have to figure out sort of the logistics of the payment and that kind of stuff. So I'm going to talk through some of the HolScience and then go on to other hacks as well. So I've ordered an instructor kit, and they sent it to me free of charge so that I can sort of play around with it. And, you know, here are some images of some of the stuff that was shipped to me. I mean, these are real lab materials, similar materials than you would get, but, you know, there are small samples of each, you know. So you have something called lab pack, is this box that they'll send, and you can set up sort of which labs you want shipped to you. So you can have a whole unit of stuff, and that's bio, chemistry, physics, and they'll ship the materials there. So you notice in the lower left-hand corner, you know, they have gloves and safety goggles. You know, there are other materials. There's sort of plastic cylinders and other kind of plastic materials. There's even a hand microscope. I mean, a small digital scale, depending on. So there, you can really recreate the lab experience at home for your students. They have an online platform, and then on this online platform, there's exploration. There's reading materials and questions for students to answer. There's a section that describes the experiment, and I'll talk about that in a moment. And then there's an assessment piece as well. They provide material lists. They're very clear about which materials HOL has sent and which materials students will need to get. And it's good to, you know, for them to see those materials in advance. So if there's stuff that they need to get, they can do that. They provide the procedures as well. And those procedures have images so students can see what to do. There's also some videos that show certain steps that for students to complete. They have a section about recording their data so that as the teacher, you can see that they recorded their data, making graphs, answering questions, so you can see the answers to their questions. And the evaluation part, you know, it actually locks down the rest of the site. And so that they can't sort of go back and review the lab materials or instructions. And there are questions for them to answer. Again, you can assign that to students. So that's hack number one, is actually mail deliver some labs. Actually, I had a recent date night with my partner where we virtually did a paint night And so now Paint Night, they're out there, they're providing opportunities for folks to do the painting at home. And the way they do it is that you can order the kits, the art kits, and have them shipped to you through Paint Night. They also have a connection with Amazon, but I think that has been shut down at the moment. But you can order those kits and they'll mail it out to you. So similar thing with HolScience, you can have the science materials sent out to your to yourself as well as to students. I think for a lot of people, that might not be realistic, but for those who have the opportunity, that is something you want to take advantage. That will recreate the lab experience as much as possible. The next labs or lab experiences are sort of low material costs, and it's sort of easier to implement. So hack number 2 are virtual labs. There are a number of virtual labs that you can access online. A lot of them are free. I provide some examples here: Beyond Labs, Praxi Labs, where the student can go into the lab. It's sort of a 3D experience. You know, they can grab some glassware and they can pour things, they can pipette, they can change the setting of pipettes, and actually go through the sort of virtual steps for how to do a lab. So I did a virtual PCR lab just the other day, just to practice. You know, you can drag, you know, so you can, it actually drags the glassware and has you pour it. And, you know, there's a part on these websites for students to collect data, to record observations. Some of these virtual labs, actually, they have a setting in which the actions happen in real time. So some of those like PCR things might actually won't be ready to an hour. But a lot of but you know, you can disable that setting and have it zoom ahead. So that's another way to sort of get some type of lab experience through a virtual 3D situation. I really like hack number 3. I use this all the time, even in my brick and mortar classes. These are simulation labs. Folks might be familiar with PhET, and PhET has tons. It's from the University of Colorado, have tons of these simulations in physics, biochemistry, and a lot of these simulations, students can change variables and collect data. So I highly recommend the interactive simulations.
Sorry, there's somebody in the chat that's saying they're a deaf teacher. Would you be able to put captions on for them?
I don't know. I don't know that I can do that. So.
There will be captioning for the recording on our YouTube channel. We'll make sure that that's available. I'm terribly sorry that we don't seem to have the capacity to provide live subtitles in this session right now, but it will be available in the recording.
Thank you.
Sure. One example, this is a simulation that I'm on the left, a simulation that I'm actually doing for my students in this upcoming distance learning unit, is this sort of epidemic simulation. And it's really wonderful. Students can, change different variables, run the experiment, and then see the data for, how many were affected, how many died. There are a lot of sort of results they can set. And then they can run the simulation multiple times, repeating the levels of the different variables, and they'll get different data each time. And then they can, it can have them do the mean and confidence intervals. And so that's I think a really useful and powerful hack are these simulation labs that are typically free of charge. You can send them the link, and that recreates some sort of lab experience. Hack number 4 are sort of the DIY. You can always do the DIY, the do-it-yourself labs. And there are a number of websites that provide instructions of how you can DIY. On the bottom left, you'll see someone DIYing gel electrophoresis, where they're, using toothpicks and tape and other materials to do gel electrophoresis. There's sort of, on the right, you see the top right, there's a chromatography lab that I have students do. Again, they just get some coffee filter paper, cut it up, some rubbing alcohol, whatever, some saran wrap. So there are a number of ways to DIY some labs where you can use you can replace household materials. Science Buddies is a site that I know a lot of students use to, especially some of the younger students use to give them inspiration for their science fair experiments. So I think it's good to take advantage, see what's on there. I looked at some Science Buddy stuff and I saw some really cool DIY experiment hacks for even upper school. A colleague of mine at HLC does AP Physics, and you can see that the image on the bottom right, I don't know how to do these. You can do these physical phone experiments where you use the sensors of the phone can collect data. So there's one experiment where you tie a string. You sort of have this little mechanism. You tie a string to your phone. You swing it as a pendulum, and the sensors that are already on the phone allows you to record certain data. As well as I saw another experiment where you could bounce a basketball next to the phone, and the microphone, because of the settings, can give you other data based on the sound of the bouncing of the basketball. So, I think you can find some DIY experiments online to recreate a lab experience. Hack number 5, there's actually, for those who subscribe to STEM Teachers NYC, there is going to be a demo later today on Zoom from the leadership team of Veneer that creates those probes that some of you might use in your classes. Veneer has this thing called Pivot Interactives, Veneer Pivot Interactives. And so hack number 5 is about video labs. And what happens is that, and with Pivot Interactives, there are recordings of certain experiments, and you are allowed to slow down the video and collect data on that experiment. So this experiment is this, someone is dropping a ice puck down an incline. And what happens is that Pivot gives you tools that you can use. So there's a stopwatch, there's a ruler, and these can be superimposed on the experiment on the screen. And then you can play the video, you can even slow it down. And then it allows you to sort of record the data. There's a data table that you record your data. So down below, you see like seconds and position. And that's a way to sort of recreate some of those experiments. I haven't played around. I'm looking forward to looking at the presentation later today. So I haven't played around with any of their bio or other stuff that they have, but I saw this one. I thought it was really cool. The DNA Learning Center, they're now publishing some video labs. And these are videos that students can view and interact with potentially. So that's hack number 5, those video labs. Now I just want to give some advice about best practice about how to use do labs. So I gave you some ideas of some hacks, like the video labs or simulation labs or mail deliver labs. But here, I think some best practices around doing these labs from a distance learning perspective. Instructions, giving students instructions is going to be tough. And when you're in a brick and mortar class, a lot of times you're right next to your students and you can point out errors. You can rely on sort of synchronous real-time corrections. So giving instructions, making sure your instructions are clear is going to be even more important than in a brick and mortar class. So what I like to do is I like to provide, sometimes I create labcasts. Labcasts is sort of a play on the word podcast and screencast. And I record videos demonstrating how to do certain steps of the labs as sort of a way to demonstrate the steps. Alternatively, you can have your written instructions, but embed images in your instructions so that the instructions are clear to your students. Because again, you won't have some of the interventions available to you than you usually have. It's important that you share your materials list in advance. So when students are about to conduct the lab for you, seeing the materials, that should not be the first time they see the materials list. Because typically students are going to need to get organized and get materials, and maybe someone has to do a run to the grocery store or something like that. So if you're doing, especially some of those DIY labs, make sure they have those materials in advance. So even at the beginning of the week or the beginning of the unit, say, there's going to be a lab, and I just want to make sure that you know what materials to get, and go out and get those materials before you actually get the lab. When students are doing these labs, they're doing it, they're doing it at home for these lab experiences. So typically they're not going to be able to have repeat trials. They're going to have limited resources. And so I think it's very important that you crowdsource data. So if you're doing those mail deliver labs or some of those DIY labs or whatever labs you're doing, in order for students to get those repeat trials, the data to run statistical analysis, crowdsource the data. So send out a Google form where they after they do the lab, they send the data through a Google form, or you can have a shared Google spreadsheet in which you clearly identify, where folks are adding their data on the spreadsheet, have a designated space. And then, students can start doing those statistical analysis. I worry about in the distance learning situation that we might send our students to do a lab. They're realistically going to be able to do one or two trials, but that's not best science. Best science is having the repeat trials. So one way you can sort of do that is have the crowdsourced data. Because we don't want to making claims or conclusions without doing some kind of statistical analysis on the data. I get questions about, well, how do I know students have completed a lab or hands-on activity? And I definitely would require them to show some kind of evidence. So, on the left, this is not a lab, this is a hands-on model building challenge that I had students do. But they had to record a video. They had to send me the video or send me the link of their video showing, this is my model of DNA. It's their voice. Sometimes they're in the video. If it's not a video, then you might have them send images and, and be clear about what kind of images you want to see. I want a close-up of this setup. I want to see you in the image doing this, so think about how you're going to require evidence of completing a lab, because what we don't want to do is sort of students fudging data and sending off data to you. We want them as much as possible doing having some of these experiences. It's not foolproof, obviously, but that's some way to make it clear to students that no, you want them to participate in the lab or hands-on experience. Moving on to hack number 6. So let's say if there is no simulation for the lab you want to do. Let's say there's no DIY way to do it. Let's say you can't mail it. I think this is the point in time where you can be creative and just assume that for certain labs and some activities, they're not going to be able to do the entire lab from start to finish. So whether that's the designing the lab all the way to collecting and presenting the data or doing the write-up, maybe for certain labs, maybe you don't have them do one step of it. So maybe at the beginning, maybe you're going to give them the experiment procedure, and you're going to give them the data and the graphs or whatever you want. But maybe all you can do is at the beginning, hey, we're going to answer this question. I want you to take an initial stab at designing an experiment. What would you do? What materials would you need? What steps would you do? Maybe you're giving them the raw data. Maybe there's some data you found online from from an article or something, and maybe you send them the raw data. Look, for this step, for this experiment, we're not going to be able to do this experiment. This was data that was collected. Now I need you to go through this data, organize it, figure out how to display it, and come up with an explanation of why this is the best way to display the data. Maybe they're creating the graphs. Thinking back to those video labs that I talked about, Maybe there's a way that you're recording yourself doing the video, or you have images doing the video, and maybe there's a way for them to record data from those images or videos, you know, so maybe it's a close-up of your cylinders or your measuring cups, and maybe, okay, here are the different results. I need you to record the, you know, I need you to look at the image and record the data and then organize it, you know. And maybe they can't do any of those steps, and maybe they're going out and they're presenting an experiment, you know. So maybe, you know, they have different experiments, the procedures are given to them, the data is given to them, and then their job is to summarize it, present it, or write a lab report or something. So I think in those partial labs, think about that. Don't assume that, you know, hey, if I can't do the entire experiment, there's no benefit of doing anything. You can still get students practicing some aspects of the scientific process, even if they can't actually recreate the entire experiment. But that's my advice for partial labs. The next hack related to labs, these are not actually labs, these are case studies. The University of Buffalo has this wonderful website, the National Center for Case Study Teaching and Science. I highly recommend, even, you know, even after the current crisis, I find these, you should think about using these case studies. They have it in, they have a lot in bio, they have some in physics and chemistry. These are wonderful resources. And what's great about it is that, yes, I think you have to pay something like $20 each year to access these, at least access the answer keys to the case studies. And if you do this, definitely they ask you not to post any answer keys to students, because then these resources become less valuable to all of us who are using the resources. So there's a whole library of case studies, really interesting case studies based on real science, current science. And so my suggestion for this hack is look through the case studies in which students are actually playing the role of scientists. So maybe, yes, they can't do the labs, but maybe they can engage in scientific thinking. These are examples of two of my favorite case studies. There's a case study that I use with my students that's the evolution of human skin color, and they get data about, and they start thinking about coming up with Darwinian hypotheses for why we see different skin colors in the human population. So they, you know, develop different hypotheses, then they get data about, and they start to rule out certain ideas, like, you know, maybe skin cancer is not a great explanation for why we see different skin colors. But they go through the process, thinking of a scientist, coming up with hypotheses, getting data, refuting hypotheses, and then they arrive at some really interesting hypotheses that are still currently being discussed. Murder by HIV, I really recommend, this is a really wonderful case study. It's based off, I don't know if you are familiar with, there was a doctor who was arrested, who was accused of intentionally injecting his ex-girlfriend with HIV as a sort of retaliation. He was also her provider, so that's an interesting dilemma thing there. But so this ex-girlfriend tested HIV positive. So the case study brings them through the process of going to the NCBI website, retrieving DNA sequences of the HIV found in the former girlfriend, the RNA sequences of the HIV found in the girlfriend, the former girlfriend, the people in Louisiana, some sequences in US, as well as sequences found in patients and that doctor was serving. And so they go through sort of these steps of analyzing the sequences, creating cladograms, and determining, does it look like the data suggests that this doctor in fact did or did not infect this person with HIV. So this is a wonderful case study, and these case studies are based on real, true science, interesting topics, and you can pick case studies in which students play the role of scientists. So that's another way to get scientific processes done by students. The last part of this presentation, I'll talk about sort of ideas for content delivery and some best practices about how do we get students to learn the information that we want to do. So we talked about some of the, have them engage in scientific processes. Now I want to move on to content. Hack number 5, look, this is a crazy time. And if you're getting direction from your department chair or other division leadership that you have to resume the normal content that you always been doing, I would tell them that, well, my thing is they don't know what they don't know what they're doing. They're giving you bad information. There's going to be some things that you can't do right now, and you have to really be flexible and honest about what you can do. So for example, I teach a biotech research class to juniors or seniors, and our culminating quarter project, we were submitting experiments. Well, we've already submitted experiments. We were going to go through the process of collecting data for a competition, an urban DNA barcoding competition, which students were going to go out into the field, collect their samples. We're going to go back into the lab, extract the DNA from these samples, amplify it using PCR, sending it off to the lab, getting those DNA sequences, analyzing it. And that's just not realistic. And the equipment, I mean, the students are not going to have thermal cyclers and centrifuges and all that stuff at home. So my last unit, we're learning about infectious diseases. I think it's a really relevant topic to be learning about at this moment. And so I changed my plan. So fourth quarter, we're diving into infectious diseases. We're learning about COVID-19. And we're doing content around that. So hack number 8 is rethink some of the stuff that you have to do. So if that means you have to rethink your units or some of the ideas or content or some of the tasks that you have your students do or how you assess, be willing and be open and be flexible to doing that. Hack number 9, I definitely highly recommend that if you're a person who gives direct instruction, to offload that in video. There are wonderful free apps and software that allows you to do a screen recording, to tape yourself, and you can send them the link to these videos. If you have a Mac, QuickTime has a native app. The MacBooks have a native app called QuickTime, and there's a feature under the file menu that allows you to do a new screen recording. And you can sort of a quick, easy way to do it is, screen record your Google slides or your PowerPoint slides, narrate over those slides, be done with it, export it, send the link to students, and they can watch a video of you doing direct instruction. For those who don't have Macs, there's a free software called Screencast-O-Matic, and that is an online platform, so it doesn't matter what kind of device you have, and you can do the same thing using Screencast-O-Matic. What's cool about Screencast-O-Matic is you could also show your face in the video. So it has a little video, screen and video thing. And it gives you some low power editing. But during this time, I would say, don't spend a lot of time making a perfect video. We just don't have the time and really the bandwidth to spend a lot of time geeking out about videos. I happen to use Camtasia, and so I do really spend a lot of time editing my videos. But I think for those that this is new to, you should really kind of think about, do a virtual whiteboard, record yourself talking over a whiteboard, or record yourself talking over some slides and call it a day. I'm going to give you some best practices around videos. I've been doing video instruction for a long time. And I would say that, when students watch, there's a difference between watching a movie and watching an instruction video. The movie, you can be really passive, while watching video for instructional purposes, that is you want that to be an active process. So one thing I do is I provide a note template that I send to students that they can make a copy of and edit. And I sort of put in some, some of the information, and they have to fill in the rest of the information. For folks who are taking notes from videos, they may not quite understand what's the most important information. So definitely, I would provide a notes template. I would engage them in checks for understanding. There's some things like Edpuzzle or PlayPosit, or you can, as you're recording the video, you can ask the question during the video. Just have a time for them to make sure that they're pausing and then stopping and thinking about what you're saying or what you're showing, answer questions. You can do it after the video. So maybe you have like a link to a Google form, or if your learning management system has like an online assessment feature, you can have questions that they have to answer after the video. So definitely have some mechanism for checking that they understood your video content. I also provide opportunity for students to ask questions after they, either during or after they watch a video. So I open up a discussion thread on my learning management system in which students are able to ask questions, and then I can go in and reply to some of those questions, or or have other students reply to those discussion questions. I think there's been, when I first started talking about flipped learning, a number of folks who were concerned that, well, students are not going to have an opportunity to ask questions and they might get confused during the video. And I would say, yes, I understand that concern, but if you give them an opportunity to ask a question online, they can do that. In addition, I would say that I moved to a asynchronous flip model, a flipped learning model, in which students were actually watching videos during class time, as well as doing labs and other stuff. And I would say of years of doing that, maybe I had 2 questions from a student while they're watching a video. So I would say it might seem sort of like, oh, students need in the moment to ask their questions in order to understand the videos. But my experience is that that's not necessarily the case, especially if you're trying to make your videos as clear as possible. I like to have a mechanism to get feedback about my videos. And during the summer, I typically go through the feedback and identify which videos I need to revisit or redo based on the comments from students. This is not a mandatory thing, but I think it's a best practice. So as you're thinking about videos that you want to change, or if there's support you need to give or clarify something from a video, getting that feedback from your students and making it anonymous is a great way for students to be able to share concerns or things that are that could be improved, so that you can either clarify or revise videos. So I would have some mechanism for them to get feedback to you. One thing I could point out is that these don't all have to be different things. Like the Google form for the feedback can also be part of the same Google form in which you're having where they can submit questions, as well as where you can have some checks from understanding where they can submit answers to questions. Another content delivery thing, hack number 10, is I would definitely look into getting e-textbooks. There are some wonderful free online textbooks. CK12 happens to be one that I really like. They have content for all different types of science, as well as non-science. So if you have friends who are English teachers or history teachers, you can point them in that direction. It's free. They have different grade ranges. So they have high school versions of content, middle school versions of content. They have a lot of interactive features that I'm going to show in a moment. And it's customizable. So you can sort of create your own version of the textbook and grab a chapter from, grab some chapters from one book, grab chapters from others, or grab only some chapters, and you can assign it to your students. So I find CK12 a great online or e-textbook. And so I'm just gonna show some quick images from their website or their ebook. So you can see it has, chapter outlines, and then it has the text and images and videos within the chapter. There's a feature, an annotation feature, where students can highlight text or add notes to text. And I would say I'm fully aware that e-textbooks, that's not best practice for, like, you know, if you're in a brick and mortar class, that you really want students reading real textbooks and being able to write in books. And you know, the data tells us that when students are writing in margins and using physical books, that is best practice. But I think in the moment, this is what we have available to us. Some of these e-textbooks, they have checks for understanding, so students can answer questions. There's some interactive features. I was playing around with this interactive feature here where students can actually drag and drop maybe it's hydrogen or different other groups and drag it to the template for an amino acid, and then it shows them what amino acid they have created, and then there's some accompanying questions that go along with the interactive feature. For those who are familiar with Khan Academy and some of those other platforms where you can do some grading and assign homework, and you can track their homework, this particular e-textbook allows you to keep track. You can set up classes in the platform and get access to data for how your students are answering questions. So that's hack number 10. A way to deliver content is through those e-textbooks. The other hack was, of course, video lectures. Pogos, I really highly recommend. Pogo stands for Process-Oriented Guided Inquiry Learning. I've seen it also as Process-Oriented Guided Inquiry Lessons. Pogos are basically kind of like worksheets, but they're structured in a way that that students sort of, they arrive at the conclusions rather than you sort of lecturing them the conclusions, and they they arrive at the understandings rather than you telling them. And talk through some of those. Flynn Scientific, they sell PDFs of their Pogos. They've developed a lot of content around Pogos. So they have it in different types of sciences, chemistry, earth science, physics. So you can get those. Here's a screenshot on the right of a page of the acid, strong versus weak acids, Pogo from the chemistry series. And these are really well done. I'm going to talk through the anatomy of a Pogo in a moment. So in the Pogo itself, so I would think about it as like a worksheet on steroids. There's typically an introduction, and then it goes through these models where students are looking at diagrams, they're looking at data, they're looking at images, and through analyzing the models, the images, the graphs, you propose questions that get them to arrive at, the conclusions. So in this is a, some screenshots from a Pogo I developed about blood typing, in which rather than sort of telling them, oh, these are the universal donors and the universal recipients, and this is how it works, I take them through a series of models where I use questioning arcs, and I start off with low Bloom's questions about, do you understand the model? And then get them to more sophisticated questions and where they're developing their understanding. And so by the end of this Pogo, they have an understanding of, oh, this is why, this blood type is a universal donor. This is why it's a universal recipient. This is why there are miscarriages and in what scenario there are miscarriages, and things about organ rejection. And it's not through me telling them something or them reading text, or it's really through the questions based on the models. And then you see throughout the Pogo, there are these key symbols that let students know, hey, this question, the answer to this question, you need to commit to memory. And then there are these stopping points where students stop, they get feedback from you, so that if Pogos are typically built on sort of prior learning leads to more sophisticated learning. So you don't want them to go through the entire sheet without getting feedback. Oops. So my suggestion is I would hack the Pogo. I would create a Google Doc version of a Pogo, share that Google Doc with certain groups of students so that they can collaborate on the Pogo. And that's a way to get some interaction between students. And then, and then you can use the comment feature to give feedback to students throughout the process. And you can give them instructions. Don't go past this stop signal sign until I've given you feedback. And you could use the comment feature in order to address things that are incorrect, or you want them to go back to different questions. And so that's a way of hacking the Pogo, as well as any other worksheet or activity sheet that you want students to do that you want them to collaborate on. Create a Google Doc version of that, have it shared with the groups that you want to assign, and have them work on it while you give feedback. That's what I'm doing with lab reports this quarter. Is I'm having them share lab reports, and I'm going in from time to time giving them feedback. This is related to a different sort of best practice that I talked about in a previous NYSAIS seminar that I led last Friday. Is that in a distance learning class, you want to build in as much interaction as possible so that students are not isolated. They're more likely to complete your work if they're working with each other, if they're giving feedback to each other, if you're giving them feedback. I think the thing I would not suggest you do is assigning a bunch of work and saying it's due at the end of the week or the end of 2 weeks, and then you'll find that some students are not working on it. So again, I would hack it by creating a Google Doc version of it and then sharing it out. I do want to leave some time for questions, but I wanted to remind you of some of the hacks that I talked about today. So for science instruction, there are different ways of approaching labs, whether it's HOL mail deliver labs to virtual labs and simulation labs, do-it-yourself labs, video labs and partial labs, as well as considering the use of case studies where they're at least participating in the process of thinking like a scientist. For delivering content, I would suggest folks rethink about what content they actually want to teach, as well as delivering content through a combination of video lectures, e-textbooks, and virtual Pogos. This slide deck will be shared. There is an effort by a bunch of teachers. There's a link of e-learning resources that folks are submitting links to wonderful e-sources in different disciplines, not just science, but other stuff. And I would definitely check it out. And if you would like to stay in contact, you can reach me on Twitter at Wilson's Biolab. All right, thank you, folks. And we have a few minutes, but I want to, if there were any pressing questions that either Barbara or George wanted to surface, I can address those.
There were some questions about assessments and grading at this time when things are being done all differently and online.
Yes, in fact, I initially planned to talk about assessments in this session, but as I was developing content, I realized that I wasn't going to be able to get through it. But I did address content in last week's seminar. Barbara and George can point you to that recording, and I address some ideas about assessments. One thing I would plug is the use of DigiExam, which is an online platform that allows you to create exams, and it has some protections against breaches of academic integrity, in which it locks down the computer of the student so that they can't open up other apps, they can't open up other web browsers, and they're stuck until they finish doing the exam. So DigiExam is something you may want to have your school look into launching for you. There is a cost, there is a license, but that looks like the best test platform online at the moment. So definitely look up DigiExam.